Hello everyone, this is Arit Chandar from KP Classes, and in today's video we will be looking into the numerical questions of the common part of GATE 2025 question paper. As you are aware, the official question paper answer key, preliminary answer key has been released by the GATE authorities, and I hope you have all cross-checked your marks as well. Now the there is a bit of time, like we'll be expecting the result in probably next 2 weeks, 3 weeks. Within next 3 weeks we'll be having the final result of the GATE examination. So in this video we will be looking into the solutions of the numerical part. Before I start with the solutions, there are two important points. Number one, it is an observation with respect to this year's GATE paper. If you compare it with the last year's paper in terms of numericals, because today's video is focused on the numerical questions, let me briefly tell you a simple data point. In GATE 2024, from the common part there were a total of 8 numerical questions. 8 NAT questions were asked in 2024 paper, and this year the total number of numericals just in the common part has increased to 12 questions. As you are aware, there is no fixed pattern as to how many numericals will be asked in the GATE paper, but this year the total number of numerical questions has increased by 50% in the common part. If you look at the overall paper also, something which is deviation from past pattern in this year's paper is students who have attempted the planning part. There are only 3 numericals in the planning part this year, but in the architecture part I think there were 5 numerical questions instead of 3. So the distribution in terms of number of numericals was not same for all the parts, for both the parts of architecture and planning. That's a minor observation, but more important is you can see that the number of numericals has increased drastically this year compared to the last year's paper. That can make the paper look a bit lengthy. So however, to get an idea, so if you have cross-checked your marks and if you want to get an idea on your expected rank, we at KP Classes have released, or we have shared a link for a form. You'll find the link for the form in the description of this video. You can click on that form and answer the questions in that survey, and you will get an update from our end with respect to your predicted rank and also the predicted cutoff. So as we collect the higher, as we get on keep on getting higher quantity of information, we'll be in a better situation to expect the exact cutoff and your rank. So ensure, so make sure, if you have cross-checked your marks, make sure you do respond to that link, the survey link which has been given in the description of this video. So with that, let us begin with the session for this particular video, wherein we'll be focusing, like I said, we'll solve all the 12 numericals of the common part of the 2025 question paper. The pattern from numerical point of view is more or less as what can be expected. So there are few questions for sure which are very new, but majority of the questions, numericals, are from those areas like what we generally expect, and there's no huge deviation from the GATE pattern in general. So let us look into the numericals. There are no 1-mark numericals this time, only 2-mark numericals. So let me start with question number 38. This question, it's related to fire demand, fire safety probably. So a city has a population of 1,75,000. That's the population given. Let me list down the given information. 1,75,000 is the population given. Then using Quichling's formula, the estimated fire demand for the city is dash liters per minute. Now this is based on it's not a conceptual question, it is more of a question based on a standard formula. Now it is based, so there are various approaches, various standard formulae for estimating the demand, water demand for fire safety in cities, of which this is one of the formula, that is Quichling's formula, which is one of the most widely used equation or formula for estimating the fire demand. You cannot derive that formula, obviously it is a standard formula. So as per the Quichling's formula, the fire demand is given by 3182 into root over P. In this equation, P is the population, but you have to remember this is not the direct population which you have 1,75,000. It is population in thousands. Population in thousands. So how many thousands is the population? 1,75,000 is 175,000. So the value of P for us for this question will be 175. So this formula will give you, it is the formula for fire demand liters in liters per minute itself. So this is 3182 root over P in liters per minute. So if you use this formula, you'll get your answer in liters per minute, which is what they are asking also. So 3182. So the answer for this question will be 3182 into root over 175. You can use your calculators. If I check the value quickly, 3182 into root over 175, the answer is coming out to be 42,093.9. So you can write it as 094 if you wish. They have asked us to give an answer in two decimal places, so you can write it as this. That would be the answer for this question. As per the official answer key, the numerical answer key, the range is given as 42,000 to 42,000, 42,200. That's the answer key given. Is given as 42,000 to 42,200 in liters per minute, which is our answer is absolutely within the range, that too in the mid range. So that would be the answer. We can as per the preliminary answer key, there is no expected change in the numerical questions for sure. In the theoretical questions also, that a major change is not expected in the answer key this year. There can be some probably few changes which can occur for sure. There is a possibility, but no major error is seen in the answer key at least. So let us look into the next one, the next numerical, that is question number 39. A rectangular plot has the dimensions of 20 into 15 meter. A building on the plot fully utilizes both FAR of 3 and ground coverage of 50%. The considering all floors have equal area, the maximum number of floors that the plot can that can be built in the plot is dash. So you have a plot, FAR is given with wherein they are saying that the complete full FAR is being utilized. Ground coverage, maximum ground coverage is given 50%, and they're saying that 50% ground coverage is also utilized. They're asking the number of floors. This is a very say a classic question of FAR related to housing, which has been asked multiple times in last if you look into last 15-20 years of papers. This is one of the most repeated type of question from housing. So let us try to answer. It's a very simple straightforward say question. So the permissible built up, probably in this case it's not even permissible. You can say the existing build up, because I have said the full FAR is utilized. So the built up of our building, that will be the plot area multiplied by the FAR value. Plot area in our case, it is 20 into 15, which is basically 300 square meter, multiplied by the FAR value, that is 3. So that is the built up area, which is 300 into 3, that will come out to be 900 square meter. That's the total built up area. And the ground coverage, which is basically the floor area of every floor, considering all floors are of equal area, they are saying. So each floor area is 50% of the plot area. So the floor area of each floor, that's same and uniform, and that will be 50% of the plot area. Plot area is 20 into 15, that is 300 square meter. Plot area is 20 meter into 15 meters, that's 300 square meters. The floor area of each floor level, that is 150 square meters. Final step, number of floor levels will be equal to the total built up area, that is 900 square meter, divided by the floor area at each level. So each floor level is 150 square meter, you'll reach one level, one floor, one more 150 square meter, you'll reach the second level. So this basically will give you the number of floors. So you will be getting your answer as 6, and there is no range in this particular question. So 6 floors It is a numerical question wherein you need to answer in integers. Exact 6 will be the correct answer for this question. Again, nothing very complex in this question. It is a very easy to score question. So this year, the number of questions, even though numericals are a bit higher in number and the paper overall is a bit lengthy compared to the last year, difficulty level, I don't personally see that there will be a huge difference in the cutoff. Probably now it depends on a lot of factors. That's the reason. Do respond to the form, the survey, because exact cutoff will not only depend on the difficulty of the paper, it depends on the relative performance, it depends on how students perceived how lengthy the question paper was from students point of view. It depends on all these aspects. Do respond to that survey and you will get an update on the information, the contact information you will be sharing. You will get an update with respect to the cutoff and the predicted rank of yours on that. So ensure you respond to that survey link. Moving on to the next question, that was a simple one. The next question is question number 40, which is related to runoff calculation from landscape. Let us look into this question. A real estate project of on a 12-hectare site consists of 6 buildings, each with a ground coverage of 3% of the site area. So there is a plot of 12 hectares, and in this 12 hectares they are saying there are 6 buildings and each building covers each with the ground coverage of 3% of the site area. If every building is occupying 3% of the site area, 6 buildings together will occupy 18%. 6 into 3, that is 18% of the site area. 18% of the site is basically covered by the buildings. That's what you understand from the first statement. 12 hectare is the plot area and there are 6 buildings, each is occupying 3% of the site area, so total 18% of the overall site area is occupied by the buildings. That's the meaning of the first sentence. The second statement, the landscape area is 40% of the site, so there is 40% of the site that is covered by the landscape, it is given. And the rest is roads, and the rest of the area or roads. So what is the remaining, the balance? For if one is 18%, the other is 40%, so those two together will be 58%, so you will be left out with 42%. The remaining 42% is covered by roads. They're saying 42% of what, of the site, that is covered by the roads. These are the 3 types of ground cover or 3 types of surface runoff you will be having in this question. Furthermore, it is given, assume the coefficient of runoff for landscape area and roads are 0.15 and 0.6 respectively. Let me write down the runoff coefficient values over here. The runoff coefficient is given. For landscape it is 0.15 and for road it is 0.6. For roads it is 0.6 and for landscape it is 0.15. These are the runoff coefficients given. Ignore the rainwater on the roof of the buildings. So you need to exclude these buildings from runoff. That's what they're saying. And also you will exclude any additional water from outside areas. Considering average intensity, average rainfall intensity of 700 mm per hour. Intensity of rainfall is given as 70 mm per hour. Right, that's the intensity. Estimated peak surface runoff from the site is dash cubic meter per second. What is the estimated runoff from the site? Estimated peak surface runoff from the site is dash cubic meter per second. Let us try to understand the total quantity of runoff in cubic meter per second for this question. Quantity of runoff is runoff coefficient multiplied by the intensity of rainfall multiplied by area, C into I into A. C is given individually for two types of surfaces. You'll need to take the overall C value, then C into I into A you will be applying in the last step. That's one method. You can do it in 2 ways. You can individually find out what is the runoff from landscape plus what is the runoff from site of roads, the roads part of the site. That way also you'll get the same answer. Otherwise, you can take out the overall average runoff coefficient. So considering these two, the overall runoff coefficient for these two together, the combined runoff coefficient will be 40% weightage will be given to 0.15. So it is 0.4 into 0.15. 0.4 is basically 40%. 40% area is landscape. So 0.4 into 0.15, that's the contribution of the landscape. Then for roads, it is 0.42 into 0.6. 0.42 into 0.6. 6. So you can multiply these and add, you will get the overall runoff coefficient of the landscape and roads together. So if I do that, 0.4 into 0.15 plus 0.42 multiplied by 0.6, it's coming out to be 0.312. P value is 0.312. The area, so this intensity, because you want an answer in cubic meter per second, you'll need to convert this into meter per second. This I, at least into meter per hour. If I convert it into meter per hour, this is going to be 0.07 in meter per hour. I'll convert that hour into seconds in the last step. So you have C, you have I, and area is 12 hectares. You have to take that area in square meter. 12 hectares in square meter will be 1,20,000 square meter, because 1 hectare is 10,000 square meter. 10,000 into 12, that is basically 1,20,000. That is A, and then you have I, that's basically 0.07 meter per hour, and C. C into I into A will give you the quantity of runoff. So the quantity of runoff will be C into I into A, that is 0.312 multiplied by the intensity 0.07 in meter per hour. If you want it in meter per second, you will divide it by 3600. It's simply this way. In the denominator, you have 1 hour. In the place of 1 hour, you will write 3600 seconds, because 1 hour is equal to 60 minutes into 60 seconds in each minute. So 3600 seconds. So C into I into area is 1,20,000. That will be the last step. You can simplify this. Let me use my calculator. C into I is 0.07, area is 1,20,000. I need to divide this by 3600, and that will give me the answer in cubic meter per second. It's coming out to be 0.728. Coming out to be 0.728. Answer after simplification, this is giving me 0.728 in the asked units, that is cubic meter per second. They want us to round off to 2 decimal places, so the final answer you can write it as 0.73. So let me make a space over here. So this was question number 40. We are getting the answer as 0.73. That's the final answer. As per the official answer key, if you see question number 40, the answer key range is given as 0.7 to 0.74. That's the range, 0.7 to 0.74. So the answer is within the range. 0.728 will be 0.73, and that will give you 2 marks. So that's about question number 40. Again, a question which is not from any new concept. The first question, I understand, it was from new concept. 39, 38 question number, that is based on something new which has never been asked in history of GATE till now. But the next two questions are something which are frequently asked and something not deviating from the standard pattern. Again, a very easy question, question number 41. I'm sure majority of the students have solved this correctly without any mistake, because it is something which is very simple and straightforward, and such questions we've practiced a lot of such questions in the classes also already, those who have attended the lectures. Estimation subject, I have told this multiple times in the class. There will be rarely a GATE architecture question paper without a question, without a numerical question from estimation and project management. I tell that every time, almost I repeat that. I have repeated that point multiple times to all the students in our classes. So the same thing has been, so there is a numerical from estimation, there is a numerical from project management, like expected every year. So and moreover, this year, like I said, there are a higher number of numericals too. Let us look into question number 41 with that. A simple question based on estimating the quantity of a semicircular arch. In a regular semicircular arch of 2-meter clear span, diagram also is given for us, 2-meter clear span. The thickness of the arch is 30 centimeters as shown in this diagram. The breadth of the wall, the thickness of the wall, or basically the depth of the arch, that is 40 centimeters. The total quantity of brickwork in the arch in cubic meters is being asked. So the approach will be following. You can solve it in multiple ways. We've learned at least 3 methods in the class already when if you have attended the lectures for estimation. We looked into different approaches, because Why do we learn different methods? Every type of question might not have the same level of, say, ease in different approaches. So depending on the type of question, some methods might look easier, but this one you can solve it in any method, you'll get the same answer. Let me simply use it, try to solve it based on similar to centerline method. So for example, this is basically the arch. I'll find, it's a prismatic solid, so I'll try to find out this area, then multiply it with the depth of 40 centimeters. So 40 centimeters, if I write it in meters, 0.4 meter is the depth. But before I multiply that 0.4 meter depth, I need to find out this area of the arch. And to find out this area, you'll need to first find out the length of this center line of the arch, then multiply it with the arch thickness. Arch thickness is 0.3. So to find out that length of the center line which I've marked, or it is also called as mean length of the arch, for that you'll need to find out this midline radius, or say the radius till the mean length. Radius till the mean length will be inner radius plus half of arch thickness. So if I mark this as R in this diagram, what is R? The radius of the mean length line, the mean length line or the center line of the arch surface, that radius R will be equal to the inner radius plus half of arch thickness. Why half of arch thickness? You have to go, so inner radius plus you need to go to the midpoint, the center, that will be half of arch thickness, this much. So inner radius, as you can see, span is 2 meter. So the inner radius is going to be 1 meter. This is 1 meter and this is 0.15, because overall thickness is 30. Half of our thickness will be 0.15. So the radius is coming out to be 1 plus basically half of arch thickness is 0.3 upon 2. That will be 1.15 meter. I've got the answer for radius. So I want a final answer in cubic meters. So I'm solving everything in meters. Radius for the mean length is coming out to be 1.15. Now what will be the length of that center line? Once you get the radius, you can find out length of the center line, or length of the, let me write it as mean length directly. The mean length of the arch will be pi into r. Why so? We've discussed this also. So for a circle, the circumference is 2 pi r. For a semicircular arc, it will be pi upon r. Sorry, pi into r. So this will come out to be pi into 1.15. You can use your calculators. For pi, you can take 3.14, or you can also use directly the value of pi which is given to you in the calculator. I'm taking it as 3.14. 3.14 into 1.15, it's coming out to be 3.611. This is the mean length of the arch in meters. Now the final the volume will basically be the mean length multiplied by the thickness multiplied by the depth. So the volume of brickwork is going to be mean length, that is basically 3.611, multiplied by the arch thickness. That will give me the shaded portion area, the red shaded portion. I'll get that by multiplying this with the arch thickness. Mean length multiplied by arch thickness will give me the area of this arch surface. You know the concept if you have studied centerline method and the and the reason for it. You know how this formula is coming. I'm not going into the basics of each and every formula now. So 3.611 into 0.3, that's the arch thickness, multiplied by the depth of the arch, that is 0.4. So simplify this and you'll get the final answer. 3.611 multiplied by 0.3 multiplied by 0.4 is giving me 0.433. That would be the final answer. I'm getting the answer as 0.433 by simplifying this particular expression. The official answer keys range also, if we check for this first question number 41, it is given as 0.41 to 0.45. So even if you take slightly different value of pi, in I took pi as 3.14. If you take the direct pi given in the calculator, or 22 by 7, probably the answer might fluctuate a bit. They have given a wide range to cater to that fluctuation, 0.41 to 0.45. 0.433 is the exact answer. You can write it as 0.43 if you want to round off to 2 decimal places like it is being asked in the question. That was question number 41. Again, a very simple question from an expected area of expected model. Next one, 42 question number, which is based on finding out the scale of a map basically. Question number 42. A roof area of 6,000 square meter of a building is drafted on a drawing sheet of on a drawing sheet as 240 centimeters square. So what is the actual area? That is 6,000 square meter. What is the area on the map? I'll write it as map area or drawing area, area in the drawing, or let me write it as map. You can write it as drawing area in the drawing. That is 240 centimeter square. The scale is 1 is 2 dash, that you have to find out. Now there is a standard formula for it, but I personally, like I always tell you, GATE is a conceptual exam. You have to minimize things you by heart, and at least if you are remembering of a formula, you need to know the reason behind it wherever possible. Obviously, like the first question we solved, that equation we cannot derive. There's no other option than remembering it. But in cases where you can't remember the formula, you need to know the logic behind it. Let me tell you the logic behind this particular. So first, let us try to understand and solve it conceptually. I'll also give you the formula towards the end. So scale, in order to calculate, scale is nothing but the ratio. So basically 1 centimeter of map is how many centimeters actually. That's what you need to calculate in this question. So for that, whenever you have questions based on area, you will need to first convert it, because scale is always in terms of length. So you need to first convert it into length. So for example, 6,000 square meter, if you assume this actual area of 6,000 meters square as a square plot, what will be the side of the square? Square root of 6,000, 77.46. This is what it will be, the side of the square. Now because it is decimals, it can be, you'll get the answer even if you take assume square. So you can assume any plot square also and solve it. But for a better calculation, let me take some plot size wherein you will not have any decimals. So basically if I assume this as a rectangular plot, 6,000, let us say something like, so this is also 240, right? So you can probably uh, write this in multiples of 3 and 2, something of 3 is to 2 proportion. So if I take that, this will be, let us say, you can either take 6,000 as 30 or 300 into 20, right? You can write it this way, something of this sort. Can we write in the similar proportion? Can you write 240 also similarly? Oh, so probably 6 fours 24, right? So 6 is to 4. You can write it in that manner. You can write 240 centimeter square as 60 centimeter cross 40 centimeter or 4 centimeter, right? So that will be 240. And 6,000 I can write it as 300 meter cross 20 meter. So I'm trying to create a plot dimension based on the case. So the proportion is same in the drawing, and also the ratio is same. The ratio of this and this, if you see, that is coming out to be same. So you can write it either in this manner, or you can also take it as square. Like I said, I'll do it in both ways for you. So if I assume this dimension of the plot, so let us say the plot dimension is 300 meter by 20 meter. And in the drawing, which is a scaled down version, this will be 60 centimeter and this will be 4 centimeter. Now you can take up any one of these dimensions to find out the scale. Let me take the smaller numbers for easier calculation. So in the drawing, 4 centimeters, in actual terms it translates to 20 meter. Now what is it in centimeters? 20 meter in centimeter will be 20 into 100, that is 2000 centimeter. 20 meter will be 2000 centimeter. If 4 centimeter is 2000 centimeter, 1 centimeter will be how much on in actual terms? That's what you need to find out. What is the meaning of ratio, the scale? 1 centimeter of map corresponds to how much, how many units, how many centimeters in actual terms. If 4 centimeters is 2000 centimeter, 1 centimeter is going to be 2000 divided by 4. That will come out to be 500 centimeters. So the scale is 1 is to 500. They have already written 1 is to, so your answer for this question will be 500. Answer in the nearest integer, so exact 500 will be the answer. This is one approach. Alternatively, if you cannot think up about factorization in similar proportion for the actual drawing and also for the map, alternatively you can also assume a square and solve it. If you assume a square plot, if the area is 6,000 square meter, like I said, the side of it is translating to square root of 6,000. That will come out to be how much? 70. 7.46. It will be meters, right? 77.46 meter. Similarly, the scaled down version of it in the drawing, this is 240 square meter. So sorry, square centimeter. 240 centimeter square. So what is the side of this square? It is square root of 240. You can find that out using your calculator. It is coming out to be 15.49. 15.49 in centimeters. Now 15.49 centimeters in the drawing is equal to 15.49 centimeter in the drawing is equal to 77.46 meter, which in centimeters will be 7746 centimeter. So what will be the value of 1 centimeter? It will be 7746 unitary method. If 15.49 is 7746, 1 centimeter will be how much? 7746 divided by 15.49. Simplify this and you'll get the answer. 7746 divided by 15.49. 500.06 you're getting, rounded off 500.06, rounded off to the closest integer, it will be 1:500 again. You're getting the exact same answer. So if you cannot think about factorization of the actual and the actual map, actual plot and the drawing in a similar proportion, if you cannot think of such factorization, you can directly assume square and solve it. You will get the answer even that way. Finally, the formula, there's a standard formula also for this. For area, if you are having area given, the scale in terms of area will be given this way. The scale of a map in terms of area is 1:, square root of the actual area divided by area in the drawing. Right? So if I apply this formula, so this is what I need to calculate. So square root of the actual area is 6000 square meter, but it is square meter. You need to convert into same units. This also should be in centimeter square. This also should be in centimeter square. Or this also should be in square meter. This also should be in square meter. Same units has to be maintained. If I want to convert this square meter into centimeter, it will be into 100 into 100 because it is square meter. Every meter you need to convert into centimeter. So into 100 divided by 240. That will be the formula. You can also simplify it using this as well. So it's 6000 into 100 into 100, divide that by 240, you'll get 2,50,000. So this is coming out to be square root of 2,50,000, which for sure is 500 again. So 1:500 again is the answer, even if you use this formula. Where are we getting this formula from? It is simply this thing itself. It is square root of 6000 converted into centimeters divided by square root of, how did I get this 15.49? This is nothing but square root of 240. So this is basically the conceptual part of it. Based on this itself, the formula is derived. For scale in terms of area, this is something which you study probably when you learn about remote sensing, GIS and the related concepts in PTM. This is the most basic thing you study under it. And even though PTM is a part of the planning part, basics questions, as we always say, basic questions from any subject can be asked into the common part, like you know. So that was asked in the common part, scale based question. I've solved it in 3 methods: factorization, simply assuming square, and also the formula approach. Try to minimize the questions where you by heart the formula. Anyways, let me not go into further detail. Next question is 43. Again, a question from housing part, wherein something that has to do with finance of housing. Let us look into this question. Housing property of 50 lakh rupees is on sale either through full down payment scheme with 8% rebate or deferred payment plan as shown in the table. A customer, after converting all the future payments in DPP using 10% annual discount rate, found the DPP scheme to be financially gainful. The customer would be able to save dash INR rupees in lakhs, dash lakh rupees they are saying, if DPP is chosen over FDP. So there are two types of schemes. So uh, I always tell this in gate numericals, if there is question wherein there are two cases, so if there is a comparison, it means you will need to solve it in two approaches, case 1, case 2. So what is the first case here? Full down payment. In full down payment scheme, so basically someone goes to buy a house of 50 lakh, and basically the person who is selling, that person is telling, if you pay full down payment, if you give the total money right now without taking any loan or any other scheme, if you directly pay the amount, that person is ready to give an 8% offer, 8% rebate. So what will be the cost in the first case? The cost in full down payment method, FDP scheme. Cost in FDP scheme will be, you want an answer in lakh rupees, so I'm not going to I'll solve everything in lakh rupees only. It is 50 lakh actually, but 8% is discount. If you remove 8%, you will be left out with 92%. I hope you are able to answer. So if the person is giving an 8% discount, it means 92% of the cost only you're going to pay in full down payment scheme. So the cost in full down payment scheme is going to be 50 into 0.92. You can use your calculators for that. 50 into 92% of it is 46 lakh rupees. It is rupees 46 lakh. That's the cost in FDP. You need to find out what is the cost in DPP scheme also. That is basically deferred payment plan. In that deferred payment plan, you are having multiple installments in future. You need to discount that into present value terms using a 10% discount. This is something we study in valuation in detail. Time value of money, relation between future value and present value. All these are future values. You need to discount them into present value terms and find out the net present value. That net present value, you need to see how much is it less or more than this. Actually they are saying DPP is better. So if you find out the net present value of all these cash flows, that will come out to be something less than this. So they're asking how much is that difference. So in cost in deferred payment plan, DPP scheme, will be equal to, you need to add the, so that basically is the net present value of future cash flows. And I'm sure you know how to find out the net present value. The simple formula is present value is equal to future value upon 1 plus r raised to the power of number of years. In our case, the rate of interest is 10%, that is 0.1. So r value is going to be 0.1. That's given. 10% is 0.1. 10% is 10 upon 100, which is 0.1, right? So that is r value. So if, let me find out the net present value now. For the first payment which is paid at the time of booking, this is down payment. So that is not a future amount. It is on that same day itself. So that will be directly 10 lakh rupees plus. After 1 year, you're going to pay 15 lakhs installment. So that 15 lakh, if you, so that's the future value. 15 lakh is a future amount divided by 1 plus r. 1 plus 0.1, that is 1.1 raised to the power of n. How many years after which you're paying this 15 lakh? N is 1 year, right? So that's how you discount a future value into present value. The next one, after 2 years, you're again paying 15 lakhs. So 15 upon 1.1 whole square it will be, because you're getting this installment after 2 years. So 1.1 whole square it is going to be, plus the last installment after 3 years is 10 lakhs. So the future value is 10 lakhs divided by 1 plus r is 1.1 to the power of 3, because that installment is after 3 years. So this will be the net present value of all the future cash flows. The future cash flows are 10, 15, 15 and 10 in lakh rupees. So that's the deferred payment plan. Obviously this is going to be better. Instead of paying all that amount 50 lakhs together, that 50 lakhs you're breaking into installments and paying with only a 10% discount rate. So in the first case, however, even you have 8% discount, even after that, that is costly, ending up to be costly. Let us see how much costly. So that's going to be 10 plus, you can use your calculators, 15 divided by 1.1. It's a simple question. This level of questions, this level of question has been asked in the past, but in the planning part, this time they've asked in the common part itself. So but we do study, I always tell valuation is a part of common part itself as per the official syllabus, and you have to follow real estate valuation as a common part subject. So that's going to be 13.63. You can write it as 64 because it is 63 plus 15 upon 1.1 whole square. That's going to be 15 divided by 1.1 square. 12.39, I'm getting 12.39 is basically 4, because it is 396. I'm rounding off properly to 2 decimal places. And finally it is 10 divided by 1.1 cube. 1.1. So that's coming out to be 7.51, right? So that's the value. So add all these together. It is 10 plus 13.64 plus 12.4 plus 7.51 is coming out to be rupees 43.55 lakh. In FDP scheme it is 46 lakhs. In DPP scheme it is 43.55 lakhs. What is the difference? 46 minus 43.55. So the difference in both the schemes, difference in costs is coming out to be 2.45 lakh rupees. 2.45 lakh. They have asked us to give an answer in lakh rupees. So you should not type, never do a mistake of typing this complete value of 2,45,000. If you do this, you will not get marks. That's an incorrect answer. 2 point, because they're asking answer in lakh rupees already. Dash lakh, 2.45 lakh is the answer. So if you select this deferred payment plan scheme over the full down payment scheme with an 8% discount, even after 8% discount, this is costly. You're going to save 2.45 lakhs in this scheme. That's what you get from time value of money concept. So that's the answer. If you look into the official answer key for question number 43, it is given as 2.3 to 2.7, which is absolutely in the range. The answer key is given as 2.3 to 2.7. Probably instead of rounding off to 2 decimals, if you round off to 4 decimals, your answer will be even more in the range, I guess. But still, 2.45 is fair enough at mid-range or slightly below mid-range, but that's fine. It is, we are very much safe than the extreme value of the range. However, that's how you solve this question based on time value of money. That brings us to the next question for us, question number 44. So I think this year the numericals are not, many numericals are not from new areas. They are from expected areas. They are for sure a bit lengthy. It will take some time for you to solve, but not difficult at all. If you had a sufficient practice in your preparation, it's very easy to score very well in the numericals. That's something which is very evident here. Next question. The population projection. You know, probably population projection is a topic of the PTM subject, that is planning technique management subject, but question from it has been asked in common part this year. So basics of we do reiterate this always. Basics of every subject you should learn. You should not leave out anything in your preparation. Let's look into this question. The population of a city in the year 2001, 2011, 2021 are recorded. So the populations are given. 2001 the population is 52,000. The population is 2011 was 76,000. Population in 2021 was 1,20,000. Population in 2031, they're asking what method are they asking us? They're asking us to calculate the average growth rate using geometric mean. How do you find out geometric mean? Geometric mean is nth root of the multiplication, the product of all the involved rates. So it's like nth root of r1 into r2 into r3 into so on till rn. This is how you calculate the geometric mean, nth root of r1 into r2 into r3 so on till rn for all the n years or n rate of interests, rate of growths. That's geometric mean. So using this geometric mean, we need to first calculate the average growth rate. Then they're saying the estimated population of the city in 2031 will be dash. So considering this r value, so first you need to find out r value, the rate of growth using geometric mean. Once you get that, using that you need to find out this next decadal growth population. So from 1,20,000 how much will it become considering that rate of interest, right? So first let us try to calculate and see what is the growth of rate growth, right? So first let us see what is the growth rate from 2001 to 2011. That is r1. That is going to be the difference, the change in the population divided by the original population. Always growth of rate is the total growth divided by the original population. Total growth, so rate of growth is nothing but the increase in population, delta in population, divided by the original population. That's how you find out the rate of growth. So what is the change in the population? That will be 76,000 minus 52,000 divided by 52,000. Original population is 52,000 in the beginning, right? So that's R1, the first growth rate. So what is the R1 value coming out to be? Let me write it over here. R1 is coming out to be, you can use your calculators to simplify this. 76,000 minus 52,000 is 24,000 divided by 52,000 is coming out to be 0.4. I'm rounding off to 4 decimal places to be at a safer limit 0.4615. That's the value of R1 I'm getting. The first growth rate from 2001 to 2011. The second growth rate R2 from 2011 to 2021. The next decadal growth rate R2 is coming out to be again change in the population, that is 1,20,000 minus 76,000 divided by the original population in the beginning is 76,000. So use your calculators and find out R2 again from it. R2 is coming out to be the growth rate for the second decade. It's 1,20,000 minus 76,000 divided by 76,000, coming out to be 0.5789. So we have the value of R1 and R2 both. From this, you need to take the average growth rate using geometric mean. So the average growth rate R is coming out to be from these two. Take a geometric mean of these two. There are only two cases, so it is square root of R1 into R2. That is 0.4615 into 0.5789. So root over R1 into R2. So the growth rate is coming out to be, find out the square root of the product of these two, square root of 0.4615 multiplied by 0.5789, square root of that. Use brackets properly when you use the when you use the calculator, the scientific calculator. It's coming out to be 0.5169, 0.5169,687, so that is 69. That's the rate of growth for the next decade. Certainly the population of 2031, that will be 1 plus r into present population, 1 plus r, because that's the growth rate. This much is added to the existing population, so it is 1 plus 0.5169, that is 1 plus r into 2021 population, that is 1,20,000. So that will give us the answer 1.5169 multiplied with 1,20,000. 1.5169 multiplied with 1,20,000. The answer for me, it is coming out to be 1,82,028. If you probably don't round, I have rounded off to 4 decimal places at every step. If you probably don't round off and solve without rounding off, if you round off to 10 decimal places, or say 5 decimal places after the point, probably you'll get an even more accurate answer. But then the official answer keys range, if you see for this question number 44, it is given as 1,79,000 to 1,84,000. 1,79,000 to 1,84,000. That's the range given for the official answer key, and our value is absolutely in the range for the given answer key. So 1,82,000 approach. So wide enough range is given, so even if you are not very accurate in rounding off, still you will get an answer within the range for sure. So it doesn't require any challenging, at least to increase the range or something of that sort. The next one, question number 45, again from fire safety. This year there are two numericals from fire safety itself, from fire safety chapter. A room having dimensions of 12 into 8 meter and height 4 meters stores a certain combustible material of volume 80 cubic meter. That's the volume of the combustible material. The density of the combustible material and the calorific value of the combustible material are given as 3 kg per cubic meter, and the calorific value is given as 4,000 kilocalorie per kg. The fire load of the room is dash kilocalorie per square meter. So basically they're talking about the fire load density, fire load per unit area in kilocalorie per square meter. So you need to first find out the fire load divided by the total floor area. Floor area is 12 into 8. Don't do a mistake of taking the total surface area. Fire load is always calculated as the total the total calorific value of all the combustible materials in the room expressed per unit area. This is a standard definition given in part 4 of NBC volume 1, the fire safety chapter. And also we have discussed this in detail and solved numericals related to it also in the classes if you have attended the lecture for fire safety. I'm sure you remember that. So the total fire load, so basically the total fire load in kilocalorie will be you'll need to multiply the calorific value with the total weight. What is the total weight? Weight of the material is not directly given. They have given volume and density. So volume into density will give you the total weight. The total weight of the material is 80 into 3. That will give us the total weight in kilograms. Multiply this with the calorific value of 4000 kilocalorie per kg. So you'll get the total fire load in kilocalorie. How much is that coming out to be? 80 into 3 into 4000. So the total fire load in kilocalories, you can use your calculators to do this calculation. 80 into 3 is 240 kg. Multiply that with 4000, 9,60,000 kilocalories. 9,60,000 is the total fire load in kilocalories. Last step, fire load density. I'm using as fire load density, but they have mentioned fire load, but they're talking about fire load density based on the measurement units. You understand that. So fire load density is coming out to be the total fire load, that is 9,60,000 in kilocalorie divided by the floor area. Floor area is 12 into 8. So that will give us the answer in kilocalorie per square meter. So even though as per NBC definition, this is given as fire load density, the fire load per unit area. But in general terms, even fire load density is interchangeably used with fire load, as you probably know. 12 into 8 in the denominator. That's coming out to be 10,000. So the official answer key is 10,000 dot exact same value without any range. You have to have the answer is exact 10,000. That's what we are getting. 10,000 is an integer answer without an answer in integer. They are saying, rounded off to the nearest integer. They are saying then 10,000 is the nearest integer which we have as the answer. Next question. So we have 3 more numericals, I guess. So we'll be solving all the numericals in this session itself. So for remaining 30 questions, we will also be having further sessions uploaded. So do stay subscribed to our YouTube channel. And meanwhile, check your score and do respond to that on the link which has been given to you in the description of this video, so that you get an update on the expected cutoff and the predicted rank for you. 46th question. A construction project consists of 4 activities. The duration, relationship, and cost parameters are given in the table. The indirect cost of the project is 5,000 per week. The project has to be completed in 12 weeks. The total project cost will be dash. They have given the list of activities, the predecessors, the duration, normal duration, crash duration, normal cost, crash cost. We've solved numericals on crashing also in the lecture. Same concept even, and this is even more simpler than what we solved because you have only 4 activities. In the classes, we take up larger networks to have a better practice. Let's start this question. So they're asking us the total project cost. The total project cost in this case, it is going to be the total, it's going to be the total direct costs. Total direct costs are these, the normal costs, plus the cost of crashing. There will be an additional cost of crashing, plus the indirect cost. Indirect cost is given as 5,000 rupees per week. So for 12 weeks, it will be 12 into 5,000, that is 60,000. So this part is clear. Indirect cost is 60,000 that you will add. You need to find out the total direct costs, total direct cost for the project, for the complete project. For any project to complete, you need to complete all the activities. So what is the total normal cost of all the activities of the project? That is called as total direct cost. So it will be 20,000 plus 30,000, that is 50,000, plus 40,000, that's coming out to be 90,000, plus 10 more thousand, that's going to be 1 lakh. So the total direct cost is 1 lakh. So 60,000 is indirect cost. All you need to do is calculate the cost of crashing. So for that, you need to draw the network, find the critical path, see what is the normal time of the project, how much extra crashing is required, and what is the cost associated with crashing. That's all what we need to do. So let me do that. We'll come back to this slide. First, let me draw the network for PQRS. P and Q have no immediate predecessor. I'm drawing activity on arrow network diagram. So this is activity P with the normal duration as 8. This is node number 2. Q with the duration of normal duration. Take normal durations always while drawing the network. So normal duration of 5 to node number 3. Then the activity R has a predecessor as P. Activity R with a duration, normal duration of 6. This is node number 4. That's the ending node because you don't find R in the immediate predecessor column. S, the immediate predecessor is Q. S also goes to the ending node. S with the duration of 4. Right. So this is the activity on arrow network diagram for that given project. There are only two paths. So what is the critical path? There is one path that is PR. The length of PR is basically 12 plus 2, that is 14 weeks. All these are in weeks. The other path you have is QS. The path QS has a total length of 9 weeks. So obviously this is the critical path. If I highlight the critical path for you, it is PR. That's the critical path we have. And for this critical path, which has a duration of 14 weeks, you need to bring down that value to 12 weeks. So 2 days of crashing is required. Which will you crash, P or R? These are the two critical activities. So among P and R, you need to find out the cost time slope. Cost time slope is difference in cost divided by difference in time. Difference in normal cost crash cost divided by difference in normal duration crash duration. That will give you the crashing cost per day, which is called as cost time slope. So the cost time slope, I'm not going into the in-depth concepts here. This is not a lecture on project management. We are trying to solve it. I assume you know all these basics. So I'm taking at a pace where you apply the concepts which you already know. So for cost time slope of P, difference in cost is 6,000 divided by difference in time is basically 3 weeks. 6,000 for 3 weeks is basically 2,000 rupees per week. That's the cost of crashing for P. What is the cost of crashing for R? It is 12,000 for 2 weeks of crashing. So it is 6,000 rupees per week. And what is the scope of crashing you have? You have scope of 3 days of crashing here, scope of 2 days of crashing here. We need only 2 days of crashing, so you can do that 2 days of crashing for P itself. So 2,000 rupees per week. We need 2 weeks of. Why do I need 2 weeks of crashing? Because they said in the question we want the project to be completed in 12 weeks. The actual duration is 14. To complete it in 12 weeks, what is the additional cost implied? That will be 2,000. You need 2 weeks of crashing. You need to reduce the duration by 2 weeks. Per week it is 2,000 rupees from the cost time slope for P. That's the cheaper activity, so I'm taking up that as the cost of crashing. So 2,000 into 2, that is 4,000 rupees. That is the total cost of crashing to achieve 12 weeks of project duration. So from all this information we get the cost of crashing, that's coming out to be 4,000 rupees. So what is the total project cost? Total direct cost, that is 1 lakh, plus total cost of crashing, that is 4,000, plus total indirect costs given as 5,000 rupees per week. So this is basically 12 weeks into 5,000, because 5,000 is the cost of indirect cost per week. For 12 weeks it will be 12 into 5,000, that is 63,000. So this is coming out to be 1,64,000 rupees. That will be the final answer for this question. I don't think there will be any range for it, because there is no rounding off error or something which can happen here. So yeah, as per the official answer key, the exact answer is 1,64,000 uh, without any rounding off or range. That's the 46th question based on crashing from project management. Next one is question from perspective, or I guess capturing it on a picture plane. Let's look into this question. Projection, basically it's based on the projection or perspective related to it. A 24 centimeter long line AB is vertically standing on a horizontal plane. So let me draw a horizontal plane. This is you have a horizontal plane. There is a line AB which is 24 centimeter in height. Then you have station point is located 18 centimeter above ground and 15 centimeter in front of line AB. So 18 centimeter, the station point is somewhere over here. They're saying station point is basically where you're going to say join the extremes of that line to capture the image. So this is the station point, which they are saying is 18 centimeter above the ground level, and the distance they are saying in front of line AB, this distance is given as 15 centimeters. Furthermore, the picture plane is located between the line and the station point perpendicular to the line of sight. The distance between the picture plane and the station point is 9 centimeters. So the picture plane is 9 centimeter away from the, so let us say, let me draw a picture plane over here. So picture plane is over here. That picture plane they are saying is at a distance of 9 centimeters from the station point. 9 centimeters from the station point. The height of the perspective view of line AB is dash centimeters. What is the length of the line captured on the picture plane as per this given information? So join the extremes of the given line to the station point. This will be the line of the image captured over here. This is the perspective of the line AB. This height they are asking us. Simple triangles, basically similar triangles approach. That's what you are going to do. The smaller triangle is similar to the larger triangle. Ratio of the sides is going to be same. Ratio of sides and the height is going to be same. Otherwise, if you want, you can draw up a perpendicular here and take right angle triangle. You can apply similar triangles concept to this smaller right angle triangle and this larger right angle triangle, right? So if you do that also, or you can also apply it for the overall triangle itself. So let me apply the concept of similar triangles. So for the larger triangle, what is the base of the larger triangle? 24 centimeters divided by height of the larger triangle is 15 centimeters. This is the ratio of base and height basically. This base, I'm taking this as the base and the height. Ratio of base and height for the larger triangle should be equal to the ratio of base and height of the smaller triangle also. So that will be equal to, what is the base of the smaller triangle? That is the projection length you need to find out, x, divided by what is the height of the smaller triangle? That is 9 centimeters. As simple as that. Simplify this and you'll get the value of x. X will be equal to 24 into 9 divided by 15. So from this you will get the value of x will be 24 into 9 divided by 15. Similar triangles approach is being applied in this question, and you'll get the answer. 24 into 9 divided by 15 is 14.4. So that's the exact answer. The height of this image will be 14.4 centimeters. The official answer keys range for this question is given, question number 47, it is given 14.2 to 14.6. which is exactly in the mid of this given range. So we are fine with this question. Number 47 for 2 marks in the GATE 2025 question paper. That we are towards the last numerical of this. Is it the last one or we have one more? I think we do have one more numerical after this. Okay, we'll solve these two. So there are two more numericals in the common part. 48 question. The view from ground to sky of a location is projected on a map as shown in the figure. The hatched and the solid black portion of the diagram represent the sky and the obstructions respectively. The radius of the whole circle shown in the figure is 3 units and the other dimensions are provided in the figure. The sky view factor of the location is dash. This concept we study in urban design. Numericals also of it are also included in our say you do have this content already discussed in our lectures, also in our, it is included in our study material as well. So it's not, it might be new for GATE exam, but it is not something which is new for students who have prepared, because it is clearly given in the study material. As you probably know, the KP GATE classes study material, which is a comprehensive compilation, it includes this concept too. So the sky view factor at a given point, it is the ratio of the area of sky visible divided by the overall area, that overall. So you need to see for the complete circle, this shaded portion is how much fraction of it. That is called a sky view factor. So for that, the total area of the circle is very simple. Total area of the circle is pi r square. R is 3. So the total area is pi into 3 square. That is 9 pi. Right? I'll write it in terms of pi itself. You need not take the value of pi further. That's the total area. Now, what is the shaded area? The sky view area, that's basically the shaded area. Now for this, it is if you can visualize this, let me try to annotate here itself. If you can visualize, you need to simplify such questions. How can we simplify this larger quarter circle, that area I can find out, pi r square by 4. Total is pi r square, pi, where r is 3, so that divide by 4, that's the quarter circle. Similarly, you have one more smaller quarter circle here. That is a quarter circle with radius 2. So you have a quarter circle with radius 3 plus quarter circle with radius 2. What are you left out after this? You're left out with two small quarter circles, which together will be a semicircle of radius 1. This plus this will be a semicircle, half of a circle, right? Each of it is a quarter circle, so two together will form a semicircle. So what is this area? Simplifying that given shape, the sky view area will basically be quarter circle of radius 3 plus quarter circle of radius 1 unit plus semicircle, because there are two quarter circles, so it is semicircle of radius 1. So this is actually 2. Quarter circle of radius 3 plus quarter circle area of radius 2 plus semicircle of radius 1. So this quarter circle of radius 3 plus quarter circle of radius 2 plus a semicircle of radius 1. So that's the sky view area. So what is the quarter circle area of radius 3? That will be pi r square by 4, where r is 3. Next, quarter circle of radius 2, again it is pi r square by 4. By 4 because it is a quarter circle. Pi r square is area of a circle. Finally, semicircle of radius 1, that will be pi r square by 2. R is 1 here. So simplify this. 3 square is 9. So this is 9 by 4 pi plus this is going to be pi plus this is going to be pi by 2. Simply add these 9 by 4. You can use it in decimal fraction if you can do. 9 upon 4 is 2.25 plus 1 pi plus zero point 0.5 half pi, that is 3.75 pi. The sky view area is coming out to be 3.75 pi. That's the sky view area. This is the total area. Sky view factor is the ratio of this and this, right? Sky view factor is going to be the sky view area, that is 3.75 pi divided by the total area, that is 9 pi. Pi and pi gets cancelled. So the sky view factor will come out to be 3.75 divided by 9, 0.4167. 0.4167 is the answer. Rounded off to two decimal places, the answer will be 0.42. That should be the answer. As for the official answer key, the range for this question 48 is 0.4 to point. It is given as 0.4 to 0.43. And our answer is exactly, actually if it is 0.4167, it is absolutely in the mid range of it, right? So that's how you solve this question. Simple question again from urban design sky view factor. Now last question, it's based on the concept of transportation, if I'm not wrong. Yep, it's based on transportation, but again, it is something which is like a question from general aptitude. It is data interpretation type question with pie chart given. Very simple question. City aims to introduce metro rail as a sustainable public transport with a projected daily ridership of 3,67,200. So they have given a projected ridership. This is question number 49, the last numerical of the common part. Ridership of the metro is given. That is, however, it is projected, but that's fine. The ridership of the metro is 3,67,200, which is expected to shift 18% of the daily trips from other modes. So this value of 3,67,200, that is basically 18% shift from other modes. So basically this is the distribution in present time. From this distribution a new sector is being formed which is 18%. Now how is that? So for something new to form as 18%, it has to take from other sectors, from other modes of transport. So that is given further. The existing modal share in percentage is shown in the figure. Half of the modal shift is expected, so the modal shift from these is happening, but of that half of the modal shift, 18% is the total modal shift. This is the modal shift which is happening, which is contributing to this much value, right? Of this modal shift of 18%, they're saying half of the modal shift is expected to replace trips by motorized two-wheeler and motorized four-wheeler in the ratio of 2:1. The trips by motorized two-wheeler after the modal shift to metro is dashed. They're asking how many people will use motorized two-wheeler after introduction of metro. So for that, you need to first find out what will be the new percentage of motorized two-wheeler ridership. The motorized two-wheeler ridership in present situation is 22%. Obviously, that will reduce after introduction of metro. How much is it going to reduce? They are saying it is reducing, so 50% of the total modal shift. That is, so half of total modal shift. How much percentage? Half of total modal shift. That will be 9%. This 9% of half of mode, they're saying clearly half of the above modal shift is expected. That is 9% of the total, say, ridership. That is basically happening from motorized two-wheeler, motorized four-wheeler in the ratio of 2 is to 1. So this 9%, you need to divide it into two parts in the ratio 2 is to 1. Two parts and one part. So that will basically be 6% and 3%. How can you divide 9% into two parts and one part? 6 is to 3, right? That's the ratio. So it's basically like this: 2 by 3 into 9. That will basically be 6%. Two parts out of total three parts, that will be 6%. So this is the modal shift from two-wheeler. They're saying two parts is from two-wheeler, one part of ratio, one part is from four-wheeler, the modal shift. So the modal shift from two-wheeler is coming out to be two parts of the half of modal shift. Half of modal shift is 9%. Two parts of it is, two parts out of three is 6%. This 6% is the modal shift from motorized two-wheeler to metro. So people from these categories are going to use metro. How many people from motorized two-wheeler are going to use metro? 6% they are going to reduce from here. Remaining 3% they are going to reduce from motorized four-wheeler. Remaining 9% that is distributed in all the remaining sectors, which we don't know. That percentage distribution is not given. They have only given us details of these two. But we are ultimately interested only in two-wheeler models, two-wheeler trips. How many people are going to use two-wheeler? Let us try to understand that. So if 6% is the modal shift away from two-wheeler to metro, what will be the percentage in the final after introduction of metro? The modal share, the modal share of motorized two-wheeler trips after introduction of metro, after adding metro, that is going to be 22% minus 6%. There's a fall of 6% ridership who are shifting to metro. So 22 minus 6, that percentage is coming out to be 16%. So 16% of the overall trips will be the answer. But that we need to know what is the overall trips. To find out the overall trips, we have this information. 18% is 6 point. So basically, if total trips is T, total trips is, let us say, T. What is 18% of T given? 18% of T is given as 3,67,200. That's the value of 18% of T. This implies the total trips T will be equal to 3,67,200 divided by 18%. 18% is 0.81, 0.18. 18% is 18 upon 100, that is 0.18. So what is the total number of trips coming out to be? 3,67,200 divided by 0.18. That is 20,40,000. That's the total number of trips you're going to have. 20,40,000 is the total number of trips. Final answer, 16% of the total. What is the 16% of 20,40,000? 20,40,000 multiplied by 0.16. That is 3,26,400. So the modal share of motorized two-wheeler trips after metro, the answer, this answer is going to be 16%. That is 0.16 into total number of trips. The value of T we have calculated. So that is coming out to be 3,26,400. That should be the answer for this question. 3,26,400. The official answer keys range is given as 3,20,000 to 3,30,000. They have given a very wide range of 3,20,000 to 3,30,000. That is the official answer keys range, and our answer is exactly within the range. 3,26,400 will be the number of trips of motorized two-wheeler after the modal shift happening to metro after introducing the metro ridership. So that's the answer for this question. Very simple one, but then it is not rather, you cannot say rather, it's not a question directly from transportation, rather it's a question on data interpretation based on pie charts and ratio percentage. If you're confident on those basics, you can easily answer this question in 2 or 3 minutes of time. So that was about it. I hope the explanation was clear for you for the numerical part. We'll come up with further videos for the explanation of the theoretical part as well, and the architecture part and planning part as well in due course of time. Do stay connected with our YouTube channel, stay subscribed to it to get further updates on this explanation videos for the 2025 GATE paper. And meanwhile, cross check your marks and also respond to the survey link which is given in the description of the video, which will enable you to get a predicted rank of yours once we collect a sufficient number of data points. So that was all for this session. Thank you, and do stay subscribed to this channel.
KP Classes, dedicated to excellence.